Hello and welcome. This is going to be our final go round for our DataMesh book club, and I'm really happy to see some of my regulars here. So I'm going to go ahead and share screen and get started. We're going to go over chapter 14. The chapters after 14 are more business focused, and so I just wanted to cover this as our last chapter as a group. And then Elliot so kindly is going to cap off our last session with a really brief update on AWS Data Zone. So thanks in advance. And really thanks to everybody who participated. So I'm going to go ahead and just share my screen here. And then we'll get started with the book. So chapter 14 was a pretty meaty chapter. Let me make it full screen here so we can see. Pretty important chapter. The stuff that, kind of makes or breaks our solution: managing, governing, and observing. And we have 3 sections here on the life cycle: governing, observing, debugging, and auditing. And a lot of the topics we've talked about already. So again, hopefully we can kind of give our usual real world flavor to this discussion, because I don't think too much of the text is going to be new. And as we're kind of all moving along in our journey towards building these data products and data meshes, because I think all of us are now at least exploring, and some of us are even POCing. This is the real world here, right? So sort of the first thing is, the life cycle, and the idea is the target state of the data. And again, I'll kind of step up first, because this is always front of my bioinformatics customers. Literally, this just happened to one of my customers again. They used, to make it very, very pragmatic, they used the default setting on buckets, which is multi-regional, and they're migrating from no cloud to cloud, and they got a big bill for data that they don't even use. So this is just kind of the old story, right? The cloud vendors default on the blob storage is, I don't know Azure, but I think AWS and GCP are the same, which is multi-regional, which is, hot storage. And for, all but my bioinformatics customers, that was never a problem, but it's continually a problem when you get massive amounts of data. So you have to think about, like in our case, we had archive data, and when we were migrating it, the mistake that the team made is a common one. They migrated it into a bucket and they didn't set it to nearline or cold line. And so they got a $5,000 bill for data that nobody's looked at for 5 years, which is just very painful. So it's just a reminder that you want the target state of the data in terms of, I think of this as hot, warm, cool, cold, whether it's in a relational database or whether it's in a blob store. And that this should be specified in a manifest. So this is kind of new thinking again. We've done this around applications, like an application could be in dev, prod, V1, whatever. But now we start applying those same kind of lifecycle thinking to data products. Like, is it V1 of a data set, right? And there is some of this in medical research already. I'd be curious if in the other domains, like education from Matt, and so just some of the other domains, have you guys ever, I've run into it. Have you run into it, versioning data sets yet?
Yeah, but me personally, like I as a kind of going between like the hot cold modality, right? And also, like, I guess, like contracts and versioning, but I've been versioning data sets at like the contract layer for a long time, so I V1, V2. People think I'm crazy creating views that are like V1, V2. I'm like, you gotta, right? So yeah, I it's part of what I do almost by default.
Well, that's because you're good at your job.
I hope so.
What about you, Matt? Has this idea of data versioning or data provenance ever come up in education?
No, because I would say, at least at our level, and K-12 is very different from higher ed, but 90% of our data is already in third-party systems. So we're at the mercy of what those systems look like. I would say 10 to 15% of our data is our own, and it evolves according to the business. And so I would just say our development team is not as big and we're not as disciplined into versioning because the latest version is whatever the latest target the business team wanted. I guess we could be specific about it. One interesting thing that comes up is we have data that hasn't been looked at in 5-10 years. And like you mentioned, but those platforms are going into life. And so now as we're going to cloud, our question is, where do we save it? Because just personally, we don't like to delete anything. Someone 3 years from now, a law changes or something says, oh, we need that data from 5 years ago. And so what we're talking about now is what is the ideal target state for an archive? Because if it's platform dependent, we might find us spinning up servers that are 10 years old just to read the file. So we're looking at delta tables and things like that. Is that the new standard that we can feel is good enough to keep old data in? I'm not sure. I'm not sure what the answer is.
You're probably on the right track, by the way. Blob storage and a forever file format.
For sure.
Mm-hmm.
And again, this concept here is to have this manifest, which is basically information about data provenance. And, you know, some of us, the more disciplined among us, Elliot, have been doing this already, but the rest of us need to get with the program here. So here it talks about the data manifest and it gives an example. And I think it's pretty good starting point. So where to find it, the URI, the output ports, the SLOs, the input ports, local policies, and importantly, the source artifacts. That really moves up in some domains like healthcare, like where did this come from? And again, the thinking is, you know, what we're doing anyway for DevOps and cloud, but it's to apply it to data. So as it says here, the aspects of a data product that are defined imperatively as code, which they say are not included here, but the way I think of it is that you have the manifest as part of the declaration. So maybe I think of it a little bit differently. So then she goes into governing, and she talks about implement the policies that govern the data products as code and embed them. We've talked about this a lot in discussing this course. You know, talk is cheap. I think this is, you know, one of those ideas that we were introduced to in this book that we've been discussing and thinking about. And as we start to build our POCs, we've been trying to figure out just how much we need, because there's a balance between deployability, practicality, and structure, if you will. One of the things I run into in healthcare is because there is such an, you know, strong regulatory environment around health data that there is just maybe, I wouldn't say too much, but I would say it's a big undertaking in some domains to do this, to have policy as code. It's a big undertaking when you're coming from, say, like a relational database and you're moving into like a data lake or a data, you know, mesh, which is multiple lakes. Because when we're in these more traditional data structures, the metadata is part of what the server provides. And I would think, Matt, you're probably struggling with this because you've got, like you were just saying, you've got these systems that are going end of life, and like, what are you going to do? Because the data is associated with the system. So this is like kind of a hard problem space for you. Yeah?
Yeah, and a lot of the governing is in the views, it's in the stored procedures, and it's the business logic. So if we don't have an app anymore because it's written on some legacy, are we rewriting the app just to keep the data accessible?
Right.
And so now we're like, well, what is the actual value? Is it the records? Is it the schema? If the data hasn't been touched 5-10 years, and really it's just in case we need to go back, and then maybe the whole entire front end isn't worth anything. We move it into Fabric or a Delta table, whatever as cheaply as possible, archive storage, put some views on top of it and call it a day. I don't know.
Yeah, yeah. Well, you know, the idea, you know, with these data products is to put the computational piece with the piece of data and make these microservices. But as we're finding, it's much easier said than done. So moving into the next subsection here, she's talking about governing data, and she's talking, kind of reminding us of some of the other ideas she talked about in terms of control. So control ports, so the ports and adapters model for data, which comes straight out of application microservices. And then the data product sidecar, we wrestled with that many chapters back. I think conceptually, I feel like I've got it, but I still didn't build one, which is basically a container that talks to a container. I know, Elliot, you were talking about several examples that made a lot of sense to me. You've built these, haven't you? You said you built one of these?
Yeah, I built and implemented sidecar architectures. Conceptually, this resonates, but I think thinking about like how you'd actually do this for like computational governance and policies and such, just still don't have that one. I get what a sidecar is. I think it makes sense, and
Right.
this whole concept of the data product container, I don't see how it comes together, right? Like it equates to the technologies that I know, but I think the technologies we know don't enable this, right? So
Yeah, we just haven't seen examples of it.
no good examples, and
Yeah.
But maybe we will soon.
Yeah, for sure. So and this is kind of the same old thing where we've got policies as code. We've seen this before. And then the tricky part, which is how much standardization and at what level. And again, this is something that I'm encountering with, I'll just make an example. I have a client that is doing research across many organizations and many clouds. And so as she says, let's look at a simple policy, access control. Well, it's simple if you're in one organization and everybody's using Active Directory. It's not simple if you're in different clouds, in different regions, in different countries, in different parts of the world. So, and more that becomes the situation. I mean, it's not everyone's situation, but I mean, that's driving data mesh, right? So this idea of access control, federation, and standardization, I mean, most of my customers, and I had some in fintech before I came into health, that needed to have the complexity that I'm seeing in health, they bought entire products to do this, to do federation, because it's so important and so difficult to do. And I just haven't seen that come into healthcare as healthcare moves to the cloud. And so it's quite a challenging area. What are you guys seeing in your domains?
So for me, this touches on the data sovereignty issue, where we're starting to see, even within the United States, different sovereignty boundaries. And Canada is another sovereignty boundary where you have, like you said, not just different policy environments, but different legal environments. And once you start getting into China and Germany, you start running into, and even more so in places like Russia, where not only can the data not leave, but and this is why data mesh becomes so powerful, because the computation has to be unified with the data. The processing has to happen in the same place. And so what you can do is you can build these analytics microservices and deploy copies of them. So you have a copy in the Germany cloud, a copy in the EU cloud, and a copy in the Canada cloud, and a copy in the California cloud. They all respond to requests the same way, so that you get the data that has been processed to the point that you're allowed to process it, and you can put it centrally. But the actual private data remains in your sovereign areas.
Yeah. All right, encryption, that's our friend, basically. So the sort of new is this idea of confidential computing. And actually, there's been announcements, and I think it was Microsoft. Jason, you probably know from Ignite. Yeah, I think
Yes.
it was. Didn't they announce confidential computing for large language models this week?
They did. In fact, they made a huge announcement. They're putting GPUs in confidential computing
Mhm.
so that you can train your own models
Mhm.
on confidential computing. You control everything. Microsoft, there's no way for Microsoft to get the data off. It is completely controlled by you. I think, especially Lynn, for your world, it's going to be huge.
Mhm.
Because especially now that they're putting the H200s in confidential computing, you're going to have that capability to train not just large language models, but large deep neural networks as well that are not just large language models.
Yeah, yeah, yep. All right. Yet another one for me. I guess it's very health-centered when I read this, but that's really just my bias. I was on a call today where we were talking about consent of patient data to be opted in for studies for cancer treatment, basically. So as it's saying here, and as we've been discussing, and it lists down at the bottom GDPR, CCPA, Australia, privacy, it is, this is a whole job area. Like if you're interested in this and you're like a network security professional or something like that, you should move into this, because I can tell you from when I try to provide architectural advisory, I generally will try to hire a subcontractor who specializes in understanding data security for the particular location and the particular vertical, because it's very, very complicated and it differs. And it's not something to just Google and go for it, because there are implications to the business, to people, there are legal implications. You need to have somebody who is ready to take on this domain when you are building. All right, data and policy integration. So again, this whole idea is everything is codified, and it's all described. It's kind of the antithesis of what Matt was talking about, the old days where we had our database servers and we had our applications, and all of this logic was in our database stored procedures and views. The idea here is to abstract that into basically textual information. Now, what's kind of interesting about this, it wouldn't be a session if I didn't talk about LLMs, because that's what's going on. Be interesting to see as LLM tools and plugins are built, if they would be built to ingest this. And I'm going to just take a little aside here and show you. So I can't remember if I've showed you guys this or not, but it's very relevant to kind of the last chapter and the future of where things are going. And this is just Ch14. It could be another example. There are custom implementations of these LLMs, and some of them you can create, and some of them the companies will create. And one of the notable ones for our situation is this data analysis GPT. And when you use this, what you can do, and I've already kind of done this just for time, is you basically upload your data set. And obviously this has to be public data, because this is public. And I just wonder, like, will these tools be augmented to be able to accept, data provenance information, right? Right now you upload the data set, and then, you give some context, and then this tool can actually provide analysis. It's interesting because this is a very specialty file type. This is a variant call format file, which is a genomic file. And it says, I don't really have the library that I would need to look at this. And see, it's actually not the appropriate library, but it's looking for a VCF module, and that's why it had an error here. But then it says, well, I'm just going to go ahead and use Python. And then it generates the code that it uses, provides a statistical analysis, and provides you with a view based on the statistical. Yeah, pretty wow. Pretty wow. And then because I asked for visualization, it also created a visualization using, the common libraries that a researcher would use. And then it kind of suggests where you might go next. Here, the bar chart shows the variants are distributed across 7 and 17, and if you need further analysis, party on, basically. So, I mean, this is, available today. And so it can, these LLMs can do, they're trained for this, can do data ingestion and analysis with very little. I mean, the prompt that I put, I need to analyze this file. And analysis should include a statistical overview of the data, as well as one or more basic visualizations. I didn't tell it this is, the only hint I gave is a bioinformatics, but I didn't tell it this is a VCF file. I didn't provide any examples. This is what's called zero-shot prompting. I didn't give it any contextual information other than bioinformatics, statistical, and a visualization. Yeah. And this is pretty darn impressive. So kind of going back to our task at hand, my thinking is, are these LLMs going to, and my guess is yes, be able to ingest data policy and apply that in whatever they do with the data. So to Matt's case, that could be really, really interesting. If you captured the code, the SQL code, well, you probably could even just save it because it's an LLM, so it could translate it to like JSON or something, right? So it really is, kind of mind-blowing, because I don't know about you guys, I keep sort of pushing the edge on what LLMs can do, and yes, I run across the same problems, like they hallucinate and they give wrong information, but what they can do already, I really I can't even think of all the things I want to try, because it's such a different way of working. My intuition is, could an LLM be the ultimate data mesh tool? Because if it were properly trained, could that be the computation, where it's just basically you're paying? It's like you're paying for tokens. Yeah. So
when you say ingesting like the policy and stuff, like from us as a K-12, are you saying like we could dump all our data into it, but it would understand whether human resources looking at it, a teacher's looking at it, a principal's looking at it, and it would automatically adjust the format and what it's allowed to share based on the user who's looking at it in the policy?
I can see that being very possible. Now, obviously, you'd have to have an internal, it wouldn't be public, right? It would be something you have to auth into it. But that's my point, actually, that could all of this provenance just be part of this LLM world? Kind of the ultimate serverless data, if you will, where you no longer don't care about VMs, or you don't care about Docker containers, and you don't care about APIs even. You just have this customized environment, and you pour your data into it. And then as administrative folks, we would have to pour our policies in to it to train it. That would be my meta point here. I'm sorry.
But how interesting would it be if the business users are the ones who are writing the policies in English?
Right.
Because isn't that one of the most complex things, is when they have a policy, we have to somehow translate that to code.
Yep.
Sometimes a mismatch.
Often.
Right.
Often, right? Like, could security be better, even with hallucinations, if policies were written in English? Because it's so different. I just had this happen, again, last week. We had some new thing, and we were testing it, and the Terraform to implement the security, the IAM policy, was missing X, Y, and Z, right? Because it's hard, right? It's difficult to do that. So, that's kind of a mind-blowing thing. Could LLMs make data security better?
It would be interesting to give it the policy and then give it a scenario and say, would this be allowed, or give me a flow chart? Because we recently worked on a project where it was a lot of computation based off the data to put students into various programs depending on their need. Well, of course, what happens is at the very end, oh, some of these students are on the wrong spot. Well, what do you mean? According to the data you gave us, it looks to us like it's correct. Oh, no. If this one flag is set, they shouldn't even fall into that area.
Mhm.
Like, you didn't tell us that. Well, now we've got to rethink all the code and the math, the logic, right?
Right.
To fit that in, where had she just described that to an LLM, basically, yeah, can we shorten that gap between when the policy is decided and when it's enacted? And if we can describe it in English, obviously there's the catch. Can you articulate this in a way
Right.
which is reasonable? But maybe we could shorten that
Right.
gap.
Well, again, I've been saying the new coding language is English, but it's a structured English.
Mhm.
Yeah.
So like, I was watching this YouTube today about is computer science education over, and this university professor said, no, but it's different because you will need to learn how to speak effectively to an LLM, right? Can't just throw, garbage in, garbage out, right? But one of the other things that's been interesting and goes to this section right here, which is observe, debug, and audit. And fun fact, I actually happen to know this guy. I spoke with him at a conference. So I was like, oh, I know Gregor. Yes, he would say that. Don't control, but observe. So the high level thing here before we bring in the LLM aspect is, as systems become more microservices, it's impossible to plan for all the interactions because it's just logical. The more pieces you have, the more the combinatorial math, right? And so you cannot lock down as you did with servers. You will miss things, right? So don't control, but observe, right? So the concept here for data mesh is that you have observability, which observability, and again, this is an area I've been working with a lot of clients, I would say over the last couple years, because it's a newer concept, even in serverless applications, right? Don't control, observe. So monitoring, I mean, the big leaders on this were Netflix with all the chaos monkeys and all that stuff that would just introduce random errors into the system so that the system could then be observed on how it responded. They were kind of, they've done it for many years, but it's taken the rest of us this long to catch up, basically. So monitor the operational health of the mesh, perform postmortem, perform audits, and understand lineage. What's interesting about this is, again, and I won't go back out to OpenAI, but I've been playing around with a lot of things. One of the things that the data GPT can already do is it can detect some data errors. So I introduced some data errors into CSV files, and it can detect and correct them. Like, you appear to be missing a comma, you have a wrong delimiter, you have an invalid character. I will make a correction with substituting what I think is the correct character and then perform the analysis. So the fact that LLMs can look for aberrations is really kind of interesting around observation, because could they do that around data information? So like very, very specifically in Matt's case, your data seems to be ABC. Suddenly I see D. They could possibly surface, which I'm going to do more testing in this, because again, there's a lot of this stuff that seems just magical. And I need to understand, because LLMs are not going to solve all the world's problems, but I think they're going to solve a lot more than we think. And when we're in a new paradigm that is very taxing for us to switch from all the ways that we managed data before, I know one thing for sure: LLMs accelerate change. And so that's why I am really exploring this in terms of data, because data is my domain. And if they can be helpful, then I think it warrants further testing. So
Definitely.
that's my soapbox. So coming back to observability, kind of pulling it back down to reality here. One of the things I find in observability is a lot of people think observability is just reading the logs. And so kind of going from the far future to the really everyday. and that's just woefully inadequate. So, needing to set up traces and metrics and alerts is kind of like table stakes. But I don't know about you guys. I don't find very many customers do this. Like, they'll read the logs, there's errors, but when I talk to them about what metrics they have set up, they look at me with a blank face.
No, data, I agree with you. Data. So I'm a data observability junkie. I've been screaming about this for a long time. even have an open source package, which is now obsolete, with great expectations and DBT and all these things. But yeah, not a lot of people do this well. Not a lot of, listen, a lot of non-data applications don't do observability very well, for sure.
Yeah.
Data, as you guys know, since you work in data, is always like a decade behind. So our industry and our specialty is even worse at it. But the good news about all of the stuff here is tooling does exist, and it's becoming more prominent.
Mm-hmm.
So of all the things so far, this is really tangible. Like, you can do all this stuff. But coming back to LLMs, going through a project right now where we're building out a platform, and we're developing like test coverage and etc. And it's like such a slog, right? Like, oh, what are the expected field values for this field, and do we expect uniqueness? And it's just monotonous, and we're probably getting it wrong. I would just love if you could just say, hey, LLM, develop a test suite for this whole thing and adjust it as needed in the future, right? That would be the dream, right? So we should go build that product.
Yeah, something else for me to try, because again, I told you guys before we started this recording, since this book club will be done, my next sort of technical exploration will be pounding on LLM. So I'm going to do 5 minutes of LLM for a while, because I'm just endlessly curious. And then along with my curiosity, because the industry focus and the resources are just extremely pointed there are just, the velocity of product releases is blowing my mind. Every week it's like we have 5 new foundational models and 16 new features and do. So I just feel like it is really kind of the next place, and figuring out how that can impact moving towards new data paradigms is like basically what I do. So anyway, so we're pretty much at the end of this. So the last thing, and I love that it's in German. I speak German. Man muss immer umkehren. One must always invert. German's so precise. And I think that, DataMesh, LLMs, if there was a bigger umkehren, I not in my technical career, right? So she says it would be invert your perspective on whose responsibility is to manage, govern, and observe data. Shift the responsibility from external party to the data product itself. And LLMs have so much potential, because, as Matt was saying, if business owners can speak, even if it's a structured English, that really has an interesting potential to involve them as well. Because for so long, the coding languages were a barrier, and the query languages. And if that's gone, that's another thing that's extremely interesting in building data products. Go ahead.
I can definitively say that the 2 items that you brought up of wouldn't it be cool if are going to show up in the next 3 months. In fact, if you want to see a really interesting implementation, I've seen a couple of data catalog GPTs that demonstrated in videos on Twitter. I'll find them. But it's the idea of integrating a data catalog, a data glossary, and a data mesh together, and having the LLM know what's in there changes the world in terms of how people interact with data. And if that product, I mean, the way things are accelerating, honestly, I expect the product will probably be out by the end of the month. I mean, I was exhausted at the end of the Dev Day presentation, and then Microsoft just, I felt like I needed a nap halfway through this keynote. But yeah, those products are coming, and the policy concept definitely is coming.
Yeah, I think so too. I think so too. It's an awesome time to be working in data.
Where do you
So, go ahead.
testing? Well, where do you see testing sitting now? Because back with test-driven development, we wrote our test cases first, right? We had to think of it. If you find a bug in the code, something happens in real time. Oh, we didn't think to test for that. Whether that was on the business side or our side or whatever. But
Well,
now,
again, I'm kind of pulling from the code side,
Yeah.
right? And I'm not really a developer. I'm kind of like a wannabe, like I build POCs, but like Copilot in particular writes unit tests great. Like,
well, what I mean though is if we switch to allowing the business unit to create policy, how do we test that? Because LLMs do hallucinate, and so me, whenever I'm writing, you know, a UI or some front end that's supposed to protect people, right? The first thing I do is I pound on that thing like crazy with lots of tests.
Right.
Well, if I'm not writing, if someone else is writing the policy, I'm sure we're still going to have testing. I'm just wondering what that's going to look like. Are we going to let an LLM write the policy and then we hammer it with tests?
Yeah. So again, I'm no expert on this. So I'm just going to give you my intuition and my little small experience. There is like more to do at the end with LLMs, with human in the middle, because it's probabilistic and there's so many variables to prompt and retrieval augmented generation and all this kind of stuff. And the safety is instead of designing requirements, verifying requirements, building the example, putting in the code in the beginning, like that's gone now. Just write it down, start going. It's at the end. It's once something is generated, looking at it, trying to figure out, is it good enough that we can test it, or do we need to start over? That's been my experience. And often when it's not good enough, it's because I didn't do a good enough job with the prompt. So again, you guys, I think I mentioned this, that I have a degree in linguistics. I have a particular sort of ear for prompt language, if you will. And I'm trying to teach myself prompt language, because as a technical instructor, that's the new code, right? Like how, not only prompt language, but prompt language by tool, by LLM, because it's going to be different. So in other words, like now we have Python and Java and what it will shortly be, it will be prompt language for ChatGPT data analysis, GPT, prompt language for BARD, prompt language for Copilot. I mean, I notice it already because I do use Copilot and ChatGPT, and that you need to speak differently to each of them, right? And so I've been thinking a lot about this, because I don't know if you guys heard, Databricks just announced an integrated GPT. And I haven't even had time to try it, but like in the data domain, there will be, it's still going to be a coding language, but it will be in more closer to English, but it's not going to be pure English because of the way technology works.
I think it's going to be a rise of DSLs, like very, like not
DSLs as we
them, but because English is not perfect either, and
for sure. And the other thing that's super handy is that I speak German pretty fluently, so I can at least test with one other language, because there's always English, and then there's this humongous drop off, which matters too for data democratization and that kind of stuff. So again, endless things. But to answer your question, Matt, my opinion is it'll be more at the end. Like we'll be testing at the end. We'll generate and test, and then iterate. But I want to close off with pragmatism. Where are we now? So Elliot's going to show us where we are now for AWS.
Yeah, no, thank you. So I had limited time to play with data zones, which is Amazon's. I don't know if they're quite describing it as a data mesh product, but it is. You know, it solves some of the problems, at least a subset of the problems. And recently I went to GA, which it's pretty narrow in scope, like in terms of what you can do with it, but you can see, and I'll walk through like some of the parts of the architecture where you can see this is much more of like a product maturing versus kind of like a POC and experiment as it was when it was pre-GA. It's a much different product.
Mhm.
And by the way, because I'm stubborn, I just started playing with it like it was the pre-GA product and couldn't get stuff to work. So I'm gonna have to back all the way back up and go through all the documentation and figure out how to use this thing properly instead of just brute force. But that's my way of learning. I usually try to get as far as I can, and then I get stuck and I struggle with it, and then I go back and I have the aha moments, you know, by actually reading the documentation and doing what I'm supposed to do. So this is and I'll try not to bounce between the data zone client and the console, just because that can be problematic with IAM and all. So we'll just stay in the console since this is a quick, the data zone portal, because this is a quick one. So what you're seeing is what an experience outside of the AWS console. So you could get to this through IAM, or you could be using Active Directory or any sort of SSO provider that you like. So that's a huge one, because we all know business people and even analysts do not want to go into the AWS console ever. And the more that AWS recognizes that, the more successful their analytic tools are going to be, including Redshift for sure. So anyway, this is what you are confronted with when you enter. There are generative AI features in here in terms of like creating metadata and so on and so forth. I think my data sets are a little too sparse because it didn't have any suggestions or really generate anything for me, although I did accept for it to go ahead and generate documentation and kind of schema. So anyway, you get this nice home page. You can browse a catalog. You can search the catalog, so I can look for, hey, do you have any employee data? Yes, you have some employee data. That's great. You can look at projects, which we'll talk about in a second. You can look at data sets, and you can just browse data and browse projects. So when you come in, you always have a context of a project. You can't not have a project, right? So you come in here, you either have a default project, you'll create a new project, or you know, you can look at some of the projects that exist. So in terms of my little story here, there's two existing projects that are data publishers. I have this employee sales project, this store master data project. Employee sales is like on top of a data lake, right? It has like a few tables in Parquet. It's registered in the Glue data catalog. It was done in lake formation, external to data zone, right? The store master data actually exists in a serverless Redshift cluster, right? Again, defined outside of data zone, but I've been able to come in here and publish my data. So let's take a look at employee sales, right? So when you enter this project, you can kind of see at first how many published assets you have, how many subscribed assets, data sources, and environments. We'll go through this in a little bit of detail. So if I go to data, you can see basically that I have inventory, right? So inventory is all the data that's available within this project. So that I have allowed this project to see, in this case, within lake formation or within the Glue data catalog. So I've allowed it to see 3 tables, right? And of these 3 tables, I'm not sure which ones it is. I think employee is published, and it actually keeps track of versioning. If you come in here and you update the metadata or you update the schema, it keeps track of versioning, which is pretty cool. You know, it has a schema, you know, it inferred some business names, you know, not very advanced. Maybe that was a little bit of generative AI that it could pick up. And it gives you like kind of a history of the data source, which actually is not very useful. I guess if I come in here, okay, you can get back to like previous schemas, I guess. But anyway, this is what my inventory looks like. You can publish some of the data. to publish the data, all you have to do is come here and publish the data asset, and it'll be available in the catalog to, I think, everybody. And then, of course, there are controls. There's a workflow about people actually subscribing to that data. One other thing that is they kind of like made more deliberate is this concept of blueprints and environments. So blueprints are like basically these packages of tools that you can have, right? So you can have a data lake blueprint. You can have a Redshift blueprint. I think as they extend this to more services, maybe you could have like a blueprint which also encompasses OpenSearch or maybe even Bedrock, right? Like just a collection of tools that are packaged together, and then you can basically instantiate them as an environment, right? And the environments are project specific. They have an ownership. Here I have a data lake environment, and if I click here, I can launch into Amazon Athena. So this is a producer project. Store management is also a producer project. If I go to environments, you will see that this has a different type of environment. This actually has a query environment for Amazon Redshift. And as you get into like the data sharing workflows and everything, when you bring the data all together, it'll actually, within your Redshift cluster, it will not only show you the data that's resident in that cluster, but it will actually magically build views of data that exists in the Glue data catalog, which you've subscribed to. So it's really pretty cool. You can have a sandbox in Redshift, you can have a sandbox in Glue, and then you can create new data assets and publish them to the world. Yeah, so if I came in here as an analyst and I was like, okay, I'm going to do my brand new data and analytics project, really I don't have any internal data sources. The only data source I have is like this default, right? The thing that I'm going to need to do is go get some data, right? So what I can do is I can go back to my home screen and I can go, okay, well, I also need, let's say, some sales data, right? I can click on that. I can learn a little bit about it. And then what I can go and do is I can subscribe. And again, I think there are some ways to modify these templates, but it's basically like, hey, I need this data to do my analysis. Click subscribe, nothing immediately happens. If I were to change back and be the role of a person who is maintaining the employee sales project, I could come in here. I could go to data. I could look for incoming requests, and I'll see, oh, I've got a request. And what is the request? Hey, I need this data to do my analysis. So you can say, sure, approve. And if you switch context back to your My Analytics project, you will now see that you have 2 subscribed data assets. Now, here's where I got stubborn and I didn't go step by step through the instructions. The model by which DataZone kind of provisions lake formation, essentially security against these objects, I didn't set up right. So it doesn't have the ability to actually manage the security of the assets. So that's what that yellow means, but we can just pretend that I did it right. So now I have these 2 assets. It could be one thing in Redshift, one thing in the data lake, or one thing in one data lake in another account, one thing in my account, and maybe some assets in Redshift. Any combination you can imagine. I could come in here to my environment and go and query the data in Amazon Athena. And if I also had a Redshift environment, I could do it that way as well, if that's what I really cared to do. So that's like a really high-level whirlwind tour of what's going on. I think the big changes are, other than the UI being improved, are really this more solid idea of what like an environment is and an environment profile and a blueprint. And obviously they've done some things in the security model and make it a little more rational. I remember, I tried to reuse some of the roles, which was probably my big problem from pre-GA, and I remember it being like completely janky to set up. That's why I stubbornly said I'm going to try to reuse this stuff, and it didn't work. So yeah, that's basically it. I'm starting to see how this would be useful to my client if they were completely AWS native, right? If everything that they needed was in an AWS environment, this would be a great way for people to pick up and subscribe data. The beauty of it being, it all ends up in tools that they're used to working with, right? You're just creating basically an environment where they can work with the data they want in Athena or work with the data that they want in Redshift, which is, pretty cool.
Well, again, I really appreciate you preparing this demo. It's really nice of you, and it's interesting to see the evolution, during the time that we've had the book club here. I'm particularly interested in environments as well, because that's the idea of bringing the compute to the data and have multiple types of compute. So it's just really interesting. So thank you. I appreciate it.
Yeah, no worries. Thank you.
Yep.
Thank you.
So great. Well, we are at the close, and so I just want to thank all you guys for participating, and thank those of you that are watching, and keep learning, and we'll see what we do next.